magnetic field force between two current carrying wires. Set up two current carrying wires. Here's wire 1, here's wire 2, each of length L next to each other. Each wire creates a magnetic field that will exert a force on the other wire. Let's start by looking at the force on wire 2 due to wire 1. Since the wires are separated by a distance d, the magnitude of the magnetic field generated by wire 1, that's this guy here, is mu0 I1 over 2 pi d, where d is the distance between the two wires. So this is the magnetic field generated by this guy that wire 2 feels. The magnetic field due to wire 1 is everywhere perpendicular to the current in wire 2. Okay, you can see the magnetic field here, how it's pointing down. So right at this point, the current's kind of going into the page. This is perpendicular to it. Again, it's a little tricky to see, but it is perpendicular. So the force will be ILB sine theta, sine of 90 is 1. So the force that wire 1 exerts on wire 2, that's a notation we've been using through this course. Wire 1 exerts a force on wire 2 of I2 LB1, right? Because you need the current of wire 2 and the magnetic field from wire 1. Now we already know what B1 is equal to. We found that on the previous slide. So we substitute that in, then we rearrange it to make it a little nice sense. And the force that wire 1 exerts on wire 2 is going to be mu0 I1 I2 times the length of the wires divided by 2 pi d. And let me erase this, and I recommend you go over the slide again without me talking, and hopefully it still makes sense to you. We can do the same thing to find the force that wire 2 exerts on wire 1, or just use Newton's third law, which of course works on magnetic and electrical forces in addition to just standard contact forces. And we can state that the magnitudes of the two forces are equal and their directions are opposite each other. Now, find the direction of each force. Are the wires attracted or repelled? And let's see, remember again. No, I don't want to erase that. The currents are both going in the same direction. What would your guess be, right? Based on everything we've done, what happens to two north poles when they're together? What happens to two positive charges when they're together? Perhaps you're predicting that these two wires will repel each other, right? Likes repel? Let's calculate it and see what happens. We'll use the right-hand grip rule for wire 1, this guy over here. So you put your thumb in this direction, wrap your fingers around the wire, and you find that the magnetic field on this side is into the page. Okay, so let me get rid of that hand. So I now have a magnetic field into the page near wire 2. I now use the right hand rule, and you put your 4 fingers in this direction. You face the palm of your hand into the page, right where the magnetic field is going. Stick your thumb out, and you find it's pointing to the left. So that the force on wire 2 due to the magnetic field of wire 1, or the force that 1 exerts on 2, is to the left, not what you may have predicted. Let's go ahead and check out what the force on wire 1 is, just to make sure that it looks like they're going to attract. Let's check that out on the next slide. Same process. We start with the right hand grip rule for wire 2, put our thumb in a direction, curl our fingers. Well, this is on the right side, but then when I curl them around to the other side, when I'm on the other side of wire 2, my fingers point out of the page. So wire 1 is in a magnetic field that is pointing out of the page. Now we use the right hand rule to find the force on wire 1. 4 fingers go up, your palm is out of the page, and when you extend your thumb, you find it's pointing to the right. So the force that wire 2 exerts on 1 is to the right. So both wires have forces that attract each other. So we make this statement right here. Wires with parallel current in the same direction attract. So sometimes intuition doesn't work. What if the currents are in opposite directions? You can probably predict this now, but we're feeling a little shaky because the last prediction may not have worked, but let's work it out. Use the right-hand grip rule for wire 1. You still find wire 1's magnetic field in the vicinity of wire 2 is into the page. But now the current in wire 2 is in the opposite direction. So we point our fingers down. Okay, we face our palm into the page. And which way is the thumb pointing now? To the right. So the force that wire 1 exerts on 2 is to the right. Let's find the force on wire 1 and make sure it's what we're now expecting. This time, I2 is in the opposite direction. So we're going to use the right-hand grip rule, put our thumb down in this direction this time, curl our fingers around. That should be your right hand, yeah. And you find the magnetic field is into the page by I1. Now I use the right-hand rule. 4 fingers go up, palm facing in, and I find that my thumb is pointing out here. So yes, it does appear the wires are repelling. So wires with parallel currents in the opposite direction, and I guess you can also call that anti-parallel, they will repel.